Cue I'm Upset by Drake. Alexa. Oh my God. So my wonderful student neglected to flag this question for me as a question that should have been solved with synthetic division. I'm at a loss for it. I have nowhere to complain other than here about the absolute triathlon that I did in order to get the answer to this dang question. It's really not that hard when you use synthetic division 2. I was really sad. So I'm going to show the way that I did it without thinking. The symbol monkey in my brain banging away. And then I'm going to show the synthetic division way to do it in a second. Or probably a couple of minutes because this is a pretty labor intensive one. So I looked at this. This is for AP Calculus exam prep. And I saw a definite integral. We know how to do those. We're familiar with those. No problem. Hi, Janie. My dog is here to keep me. Oh, thank you for the moral support, Jane. So I look at the numerator and I don't see anything that factors. I look at my coefficients. I can't pull anything out. Like, I don't really have a lot of options here. I'm kind of deadlocked in this ugly fraction that doesn't have any way of simplifying, at least up front. So what I decided to do was to evaluate this x minus 10 as a singular thing and use it to separate out my terms in the numerator. So I went ahead and said that this was equivalent to the integral from 2 to 6 of 2x squared over x minus 10 dx, because the hints, right, I knew that it was log, so we have to do something with this numerator, right? So 2x squared all over x minus 10 dx minus, I'm going to pull out the, I'll leave it because I'm going to have to do a bunch of steps after this anyway. So 21x over x minus 10. It's off to a great start. X minus 10 dx plus, I'm going to pull my 13 out. 1 over x minus 10 dx and 6. Cool. That's my first step. Now, I'm going to start by factoring out my coefficients and my numerator to clean things up. So 2 to 6, x squared, x minus 10 dx. I'm going to pull out my 21. I could have done that at the earlier step, but I'm really trying to go slow because I did make a mistake when I was doing it the long way last time. So I'm trying to make sure I do not run into the same issue because it was algebraic in nature and I want to figure out where that happened. Okay, so I have my 3 terms. I've got semi-simplified numerators. And by and large, I'm like starting to think about a different way that you could do this. This is crazy work. Okay. So it's late. It's 11 o'clock at night and I've been teaching for a couple hours at this point. So I'm going to say at this phase, across the board, I'm going to let u be equal to x minus 10. And then my du is equal to dx. No problem, right? I can't believe I did it like this. Oh my God. So if this is the case, right, at this phase, I could, right, say that if u is equal to x minus 10, x is equal to u plus 10. So I can write this as u plus 10 quantity squared all over u du, right? Cool. Then I'll get to these boundaries in a minute. I have my u, right, that I said was equal to x minus 10. So I have a 1 over u situation, du. And I said that x was again equal to u plus 10. So I'm going to make this u plus 10 here. And then I have plus 13. I'll deal with the boundaries in a minute. And then I have 1 over u du. Great. Now, from here, this is where it starts. My internal alarms of you're taking the long way around began to go off. And actually, before I proceed, I need to address these boundaries where if I plugged in 2, right, for x, I would get -8 on all these. This is -8, -8, -8. If I plugged in 2 for u here. And then if I did 6, right, I would get -4, -4, -4. So if I keep going, I'm still not in a place, I'm not in a happy place for my first 2 terms. So I'm going to keep writing it out. I'm going to go ahead. And again, I can't believe I did this. U plus 10, U plus 10, all over U, du. Again, I'm doing this really slow on purpose. -8 to -4. I'm going to split this into a u over u du minus 21 integral from -8 to -4. 1 over 10 over u, sorry, du. 13. I can do this one. So if I have the, if I'm integrating 1 over u du, this is going to be 13 times ln absolute value of u. And I'm going to keep my little boundaries of -8 to -4 here. That one is okay. For this first one, I'm going to FOIL. So switch colors. This is from -8 to -4. This is u squared plus 10u plus 10u plus 100 all over u du. This now becomes -21, -8 to -4 du, right? Because this cancels. -21, specifically -21 times 10 is -210. -8 to -4, 1 over u du. I'm going to go ahead and get started on this as a 13 times ln absolute value of u would be ln of 4 minus ln of 8. We keep going. I'm going to take this u squared plus 20u plus 100 u du. I'll address that in a second. This, if I integrate du, that's just going to be u, right? So -21 u from -8 to -4. And then this is going to be minus 210 ln absolute value of u again, right? And this would be from -8 to -4. And this is 13. ln of 4 minus ln of 8, I can condense to be ln of 4 over 8. I am shocked. My poor student just stared at me as I rattled off into the abyss. So 2, I'm going to split this one up again. So the -8, -4. This is going to be u squared over u du plus 2 -8. I was crashing out. So 20u over u du plus 2 -8 -4 times 100 over u du. Yeah. And then this one, I can -21, and I'm going to do -4 minus -8. And this one, I'll do -210 ln Absolute value of -4 is 4 minus ln of 8, similar, right? And I'm going to make this plus 13 ln of a half. Still not done. I'm going to simplify this one algebraically. I'm going to use a different color for this line. 2, -8 is -4. This now becomes u du plus 2, -8, -4. These cancel. This actually is 2 times 20, which is 40 du plus 200 1 over u du minus 21. -4 minus a -8 becomes +8. -4 plus 8 is 4. This, again, I can make 210 ln, just to keep my drawing consistent, 4 over 8. And I can separate this out again now. So ln, excuse me, can't lose my 13. 13, I'm gonna expand this again to be ln of 1 minus ln of 2. Foreshadowing. This now becomes, if I actually integrate, so -8, -4 plus 40u, -8 is -4. This is going to be plus 200 ln absolute value of u from -8, -4. 21 times 4 is 20, 40, 60, 80. 4. Same thing here. I'm going to do minus 210 ln of a half plus 13. ln of 1 is 0. Done. These cancel. I've stopped changing colors because I'm so locked in. Red. So this is going to be -4 quantity squared minus -8 quantity squared plus 40 -4 minus -8 plus 200 ln -4, sorry, ln absolute value, right? So this is going to be 4 minus ln of 8. So it'd be 4 minus 210 ln of 1 minus ln of 2. I'm not kidding. I actually did this. -4 to -4 is positive 16. This is minus 64. -4 plus 8 is positive 4. ln of 4 over 8. P4. It's 210. That becomes 0. Minus 13. I'm going to start combining like terms. So this one, this one, this one, and this one I can combine. So I'm going to cheat a little because it's late. So 16 minus 64 plus 40 times 4. If I cheat a little, I'm going to use a calculator. So this is 28. And then I'm going to get plus 200 ln of 1/2. And then I would get plus 210 ln 2. Is the negatives, yeah. Minus 13 ln 2. I'm going to take my 200 ln of 1 minus ln of 2. Yes, 28 plus 200, this cancels, minus ln 2. So I'm going to go ahead, if I pulled out the ln of 2, right, 210 minus 13 is 197. So this is plus 197 ln 2. And that's my answer. And that's correct. So I did all of that math just for us to look at the instructions. And it specified that we should be using synthetic division. So I'm going to show y'all how to do this with synthetic division. So if I let f of x be equal to 2x squared minus 21x plus 13 all over x minus 10, I can do synthetic division. Also be helpful. If I spelled it right, but we can do synthetic division. So my 0 would be 10. And then I would take the coefficients of the numerator, so 2, negative 21, and 13. I bring 2 down, I multiply. I bring down negative 1, I multiply. And this is my remainder. So now I am basically, not basically, I am able to evaluate 2 to 6 of, this is now 2x minus 1 dx. And then I would do plus 2 to 6, 3 over x minus 10 dx. And watch how easy this is. So just to keep things moving as slow as I took them in the other example, I'm going to keep this like this. And I'm going to pull out my coefficients. Cool. And I'm actually going to pull out this coefficient. Sorry. So then, I'm going to just change the color here. So if I integrate, this is going to be 2 1/2 x squared from 2 to 6. Yeah. Minus x 2 to 6 plus, and in this case, I would let u be equal to x minus 10, du to be equal to dx. So 3 integral, this is still going to be from negative 8 to negative 4 because my u is the same as it was in my original. And it would be 1 over u du. That cancels. And I'm left with 6 squared minus 2 squared minus 6 minus 2 plus 3 ln absolute value of u from -8 to -4. 36 minus 4 minus 4 plus 3 ln, like this actually, 3 ln of 4 minus ln of 8. Bad about changing this. 36 minus 8 plus 3 ln 4 over 8. There's that 28 that I was looking for. Still long, but not nearly that. And I'm wondering, as I thought through both of those answers, if it were possible at this phase, I'm not going to show it, but if we said, I recognized immediately that my u needed to be something along the lines of x minus 10. And then if I could do x equal to u plus 10, I'm assuming I could skip all of this ridiculous algebra that I did, even if I didn't see it like that, and write this as 2 times u plus 10 quantity squared. Of course it's going to work. 2 times u plus 10. I guess you would still have to do the carousel around the dummy circle for this. But then I would have plus 13 all over u. And then I could FOIL, but it would be, at least for me, more obvious that I could separate it out now that I've made my denominator one term. So this would give you the same thing as, this would also still be -8. The -8? Yeah, -8, -4. This would give you the same thing as this phase, but all in one term first. So I guess it still sucks all the same. But at any rate, this is going to be your reminder to, I don't know, check all of your simplification tools that you've been taught thus far. And specifically, remember that you can do this step, because I had forgotten that at first and was stumped. But read your directions, peace, love, synthetic division, and I will see you next time on Math Rage Bait I've experienced in real time as a tutor. So enjoy.